So you've done this before, but some of you remember, some of you forget. So I'm going to teach it as if you haven't done this before. So if you had Miss Menard or me, I taught you something called birthday cake, or if you had another teacher, there was a factor tree. I want to remind you how to do more simple problems because these numbers are kind of big. So to review, if I had the square root of 48, always start with the smallest number that can divide. So I always start with 2. So 2 goes into 48, 24 times. 2 goes into 24, 12 times. 2 goes into 12, 6 times. 2 goes into 6, 3 times. Now I can't divide by 2 anymore, so now I have to try the next number, 3. 3 divided by 3, 1. Why is it called birthday cake? Because that's like the candle, I can't make a candle, on the top of the cake. Your goal is to circle the doubles. So I would take the doubles. Let's see if I can find a different color pen. There's 1, 2, and another 2. That makes 4. And what I didn't circle, let me get a different color, goes in. So that is your simplified answer. Some of you remember it because I saw it on last week's homework. Some of you forgot, so that's why we're going over it. Okay, hopefully everybody gets happy by the time we're done. So let's start with number 1. Now you know how it goes. I'm going to do the left. Your homework is the right. Blurry that, okay? So 180, they started with a big one. We can handle it. Divide by 2. Divide by 2. Can't divide by 2 anymore, so try 3. Nope. How about 4? Nope. 5? Yes. I can go back to 3. I'm at the top of my cake. I'm super happy. So now what I'm going to do is I'll use my pink highlighter. I have a 3 and I have a 2. What do? I multiply them. Why? Because I was dividing. So to get it back, I multiply. 6. And then what didn't I circle? The 5. So 6, rad 5. All right, let's do another cake. 245. I can't divide by 2. I can't divide by 3. I can divide by 5. Let's see, 49. Okay, the only thing left to do is a 7. I'm at the top of my cake. Boom, circle the double. That's what goes on the outside. It's interesting. All these numbers end up with a 5, so that's what's going to go on the inside. Let's do more cake. Okay. I'm probably going to take up more space here. I'm going to do, let's see. I'm going to do this next one here because I don't have as much space. So 96. Oops, you can't see that. Let me zoom it out a little bit. Divide by 2. Divide by 2. Divide by 2. Know how to divide by 2. It's taking half of something, please. Divide by 2. Divide by 2. Divide by 3. All right, let's circle some doubles. We got 1, 2, and another 2. 2 and 2 make 4. And then I didn't circle my 3 and my 2. What do? Multiply them. 4 rad 6. Okay, so now I come over here, and I write 4 rad 6. Now, I want to show you something in the calculator, so hold on. So I want you to see, how did I know I was right? Square root of 96 is this crazy decimal, and 4 rad 6 is this crazy decimal. They're equivalent. Now I know that I'm good to go. All right, what's the difference between number 7 and the other ones? Well, there isn't much difference, just the A. So let's try with the 216, 2108, 254, 227, 3, 9, 3, 3, 3, 1. Okay? So I'm going to circle my doubles, which I know it's kind of hard to see. I have a 2 and I have a 3 right there. That makes 6. Now, I'm going to start my square root. And I want you to see I'm still left with the 3 and the 2. That makes 6. Now I have to acknowledge the A. So, I'm going to literally list all my A's. 1, 2, 3, 4. What did we do? We circled doubles. So what do? Circle doubles. How many doubles did I have? 2 of them. Let's try the next one. Let's do 8. 2, 4, 2, 2, 2, 1. Excuse me, itchy, sorry. circle my double, start my square root. What am I left with? 2. And then how many x's do I have? 1, 2. Circle that, and that 1x goes on the outside, just like we had before. All right, let's do 180. Well, the great thing is I already did 180, so it's 6 rad 5. Okay, now let's do the x's. 1, 2, 3. So this one gets circled, goes on the outside. What didn't get circled goes on the inside, just like the numbers. Okay, number 13. One day, a long time ago, mathematicians said, you know what, when there's a square root on the bottom, that's ugly. I don't like it. I don't want square roots on the bottom. That's the rule forever and ever and more. So they said, okay, how are you going to get rid of it? Well, they figured out that if you multiplied it by itself, what is the square root of 5 times the square root of 5? Well, the square root of 25. Well, what's the square root of 25? 5. And then they went, hey, see, look, the radical on the bottom is gone. And now I multiply 3 times rad 5 is 3 rad 5. And some people go, why? It seems like more work. Well, I don't know. We've all decided certain things in this world are ugly or pretty, and we change them based on that. We've decided as a society that if you walk around without brushing your teeth in the morning, people think that's gross. So what do? We take 2 minutes and we brush our teeth. Yeah, it's more effort, but yeah, we're all a lot happier. Okay? And the reason it is because if I asked you to go the square root of 5, which is 2.2 something, and I said how many of those and those, it's easier to quantify it when the radical is in the numerator. If you don't understand what I'm saying, you will memorize. And what will you memorize? That when you have a radical in the denominator, get rid of it. How do you get rid of it? You multiply it by itself. So I'm going to do that. If I multiply it by itself, the square root of 15 times the square root of 15 is the square root of 225. What's the square root of 225? 15. Some of you are noticing a pattern. And some of you go, do I multiply this? Well, hopefully you notice the square root of 9 is 3. So it's 3 rad 15. And some of you go, sounds good. Nope, not good. 3 goes into 15 5 times. You cannot simplify these two. This is in the radical, this is not. These are both on the outside. You can simplify them. I don't need to put a 1, but you can put it if it makes you happy, but it is ugly to me. I could take this question, put it in Desmos. I could take this answer, put it in Desmos. As long as the answers are the same, I'm good to go. Now, this one seems kind of crazy, but it's not that bad. What if I gave you 2x minus y plus 8x? What would you do? You would add 2x plus 8x. You would get 10x, and you would go, hey, you can't do anything with the y, so you'd leave it. This is the same thing. The x is the square root of 5. 7 is different. That's why it's y. Hey, the square root of 5 we said was x, so that's going to be x. So all we do is simplify. There's an imaginary, oh, that's an 8 though, so I didn't catch that. So that means this is the same as this. So that's 10 rad 5. And this is different, so you just keep it separate. Okay? Now you go, these are not the same, so you're done. No, you're not done. I could actually birthday cake the 8. You always have to check to see if you can birthday cake the square root. So this is my double. So from the 8, I get 2 and then rad 2. But I have this negative 2 here. What should I do? Well, they're being multiplied, so multiply it. Now, if you look, they are exactly the same. Negative 6, rad 2. All right, let's look at this one. And you go, cool, these are the same. I can put them together. Yes, I can. I'm going to get negative 1 rad 18 minus rad 12. Do I need the 1? No. Can I put it if it makes me happy? Yeah, it doesn't. Okay? So now I'm going to go, okay, I'm done. No, you can birthday cake 18. 18, 2, 9, 3, 3, 3, 1. There is my double. It goes on the outside. There is what I didn't circle. It goes on the inside. But there was a negative. And you're like, cool, I'm done. No, you can birthday cake the 12, so let me do it over here. 2, 6, 2, 3, 3, 1. There is my double. There is what is left. Now, can I put these together? Because that has a 2 and that has a 3. No. This is square root 2 and this is square root 3. They're different. So that means that I need you to do for homework the right side.